Hello everyone, and welcome to the last part in our series where we're going to talk about some of the finishing touches that we can put on a schematic and some of the things that we can take advantage of as we're making small changes to our schematic after we've placed most of the parts in our design. Again, my name is Adam Fuchs. I am a product engineer for Cadence Design Systems, and let's go ahead and get started. So for this video, we're going to focus on the property editor. We're going to be looking at the part manager and how we can make sure that all of our parts are up to date. We're going to look at how to annotate our design and automatically change reference designators. And then finally, how to netlist and export our design to PCB. Now, we're not going to go over the live BOM and bill of materials output. I've decided to make a separate video outside of this video series specifically on bill of materials and bill of material experts. So look forward to that one, hopefully in the next couple weeks. Let's go ahead and get started. So the first thing I want to talk about is the property editor and how we can utilize it to either review our schematic, make sure everything is as expected, or maybe make small changes to schematics at sort of a macro level. Now, the property editor can be accessed pretty much for any component, any net, any sort of object in our design, either by clicking on it and selecting edit properties, or sometimes by double clicking on a part, or even in our project panel, we can select the properties for our whole design. So if we right click on our schematic one and select edit object properties, in this case, what we can see, if we look at the bottom here, we have different tabs, all of the parts in our schematic and all of the properties that are associated with them by scrolling to the left and right. Now, you might think, well, why is this useful? This is kind of a lot of information. What this allows you to do is sort of look for maybe inconsistencies in your design, or make sure that everything in your design that needs to be of the same type is indeed of the same type. And you can even make some changes at a larger level by selecting multiple cells and editing them. However, in our case, we're not going to be making any changes for this video. This is just to show you that you can make some more changes other than through a graphical method, but also through a tabular method as well. You can also look at the schematic nets in our design. See if, for example, we want to make sure that there are no tool named nets, that every net is named. Here I can see that there are some nets that have been automatically named. Maybe I want to change those. Likewise, if I go into the pin section, I can see every single pin in my design. And this allows me to, instead of having to run a report, I can use this information and maybe export it to a spreadsheet, and then use that just to make sure that every pin in my design is connected to the appropriate net. Good for design review. Now, one of the things that I like to use it for is to quickly set certain pins as no connect. So if we remember in our past video, we had a couple different ways of setting no connect. We could select individual pins and set them as no connect, or place the no connect symbol. Another thing that we can do is simply select the part U4 and do a right click, edit properties. Now, by default, what we'll see is the part properties. So things like, what is the PCB footprint for this component? What's the reference designator? We can change that here if we want to, but what I want to actually access is the pins tab at the bottom here. And then I'll see that all of these rows that don't have a net assigned to them must be pins that aren't currently connected. So I can simply check the boxes for is no connect on those rows. And then once I get back to my schematic, these should all have the no connect symbol on them. Let's go ahead and close the property editor. And looking back here, we see that all of these X's got appropriately marked on this part. Pretty nifty tool. As you get more experience with OrCAD X, I recommend checking out the property editors for different things that you're trying to do. Maybe graphically something can be a little cumbersome, but through the property editor it might be a little easier to make some changes. All right, let's take a look at our part manager. So one of the advantages of using a managed library environment like the Component Explorer, is that as we make changes to our library, it's very easy to synchronize those changes into our schematic. And when you're using a managed library environment like the Component Explorer, we want to use that library information as the single source of truth for everything in our design environment. So that means that this R9 10K resistor, this specific part, should be the exact same 10K 1% 0603 resistor that maybe I use in another design. Likewise, it should be the exact same 10K resistor here as it is here. And if I make changes in the library, I want to be able to import those changes into my schematic. If I jump into my Component Explorer, I'm looking at this diode, the LED, the green LED. Let's go ahead and edit the part. And if you remember, one of our properties is actually annotated to the design, and that is the forward voltage property here. Now, if I were to change this to 1.0 volts, for example, and save, that forward voltage would be updated in our library, and anytime we were to place a new part, it would automatically have that new forward voltage. But if we go to our design, and I look at it here, you'll notice that this diode still only has this 1.6 volts value. And that is because as we place part from our library, they get instantiated and cached into our design, just so it's quicker to reuse those design resources if we were to, for example, copy and paste them. Now there's two methods of updating this information. One is by selecting a component instance or doing it one at a time. And the other is to run Part Manager on your whole design and to make sure that everything is up to date. So if we were to look at this single part, this D3, I know that I've made a change to it. I can do a right click and select View Database Component. Now this window, the View Database Component, my workspace, is going to give us an overview of the part. Here's all the properties. Here is the properties in our database or our library. And here are the values that are currently on the schematic. And you can see here in red, it's highlighted that the forward voltage property is different in our database than it is in our schematic. And we can go ahead and update that. And right away, you can see the value has been changed to 1.0. Save the design really quick and jump back into our Component Explorer. We're going to edit this value one more time. And we know that this green LED actually exists in two spots in our design. This time we'll change this to 0.8 volts. Save it. And let's jump back into our schematic. Now again, we are hoping that this changes to 0.8 volts, or in the case of working on a project with multiple users, maybe in a much larger library, you might not always know which components are actually not in sync. So to check which parts are in sync, in your project panel, go into the design cache, right-click on the design cache and select Part Manager. The Part Manager is basically a nice way to view all of the components in our design and make sure that they're all synchronized. And to refresh this information, simply right-click on the common and select Update All Part Status. It's going to ask us if we want to continue. Select Yes. And then we will get this little pop-up that's going to tell us that some of our parts, in this case this is DB properties and schematic properties for D1, are not matching, and the property in question is the forward voltage. And we can choose to update that. Let me just select No for now. If I select No, then looking at this large table, you can see that we have a lot of parts that are approved and are current in sync with our library. If I scroll to the bottom, we have these two parts, D1 and D3, that are not approved. Well, they are approved, but they're not current with the library and need to be updated. My personal favorite way of doing this is just right-clicking on the Update All Part Status, clicking Yes. And then as we get these differences that show up, simply click Yes to update that value. So it's going to set this 0.8 volts for the forward voltage for our D1. Say Yes. Or if you don't want to click through for every single part in your design, just say Yes to all. and then we can refresh this information, and now all of our parts have been synchronized. Going back into our schematic, we see that D3 is now 0.8 volts, and on the power page we should have one more of these diodes right here, D1 also showing 0.8 volts. So be sure to use the part manager just to make sure everything is synchronized in your design, especially when you're making a lot of library changes. It's a great way to make sure that your library is your single source of truth and that your schematic doesn't have any sort of outliers that might not be in sync with your cloud source. One more thing to talk about, and that is annotation. So annotation is the setting of reference designators and other information in our design, usually done after most of the design has been created. And that is because there are some standards that you might want to adhere to for annotation. For example, if we're looking at parts with the reference designator prefix of U, the top left corner would be U1, and then going to the right would increase, and then downwards, and then to the right again. So we'd have like U1, U2, U3, U4, etc. And the same applies for all the different reference designator prefixes as well. If we look here, we have some parts that are already not following that rule. One of the ways that we can change reference designators, as we've mentioned before, is to simply double click and update these values by hand. So I can set that to U1, I can set this to U3, and we're good to go. However, it's much better to use an automated annotation method just to make sure that we're not messing anything up. To do that, we can right-click on our howto.design and select Annotate. The window that pops up will have a couple different options that we can select from. In this case, what we want to do is annotate our whole design, so we're going to set the scope to entire design. We want to do an unconditional reference update, so that means we don't care if any of the references have been set manually or if some of the parts already have reference designators assigned. And then we want to update each individual instance. And the rest of these options, along with these advanced options, I would recommend keeping as default for now. In the future, if you have some specific needs, for example, including the page number in the reference designator, you can make changes to some of these options. For now, let's go ahead and click OK. One of the other things that's going to happen when we select the annotate, just to cancel here really quick, is these pages where right now it says sheet 1 of 1 should also get updated. So our power page says sheet 1 of 1, our micro page right now says sheet 1 of 1. So we should expect these to get updated to 1 of 3, 2 of 3, and 3 of 3. So let's go ahead and annotate. Again, entire design, unconditional reference update, and select OK. Let's look at our power page. It now says sheet 1 of 3. And if we zoom out and scroll back in here, we see that we now have J1, and here is U1 and U2. Now the only reason this one got set to U1 and this one got set to U2 is because they're at a different Z axis, I believe. Normally this one would be ahead of U2 here. Let me just make sure everything's correct. Let's try that again. Okay, there we go. We chose the right option now. We wanted to set it to left to right. So now we have U1 on the left, U2, and then U3 towards the bottom here. And then these capacitors here from left to right, C1, C2, and if we go to the right a little more, we have C3 and C4. So that is correct. And if I go to my micro page, here we have U4, and finally we have, those are the only U parts. So our annotation came through correctly. The one other thing we want to add using the annotation tool is our intersheet references. Now what the intersheet references are is, as I mentioned in the previous video, quick links or notes on our offsheet symbols, as well as ports if you're working in a hierarchical design, that will let you know where those offsheet connectors are actually pointing to. So I'm going to select entire design, click the checkbox here for add intersheet references, and then select OK. This is going to give us a couple different options on how we actually set these. For the position, you might have to change this a little bit depending on how far it gets placed from the text on your offsheet connectors, but go ahead and press OK. And then you should see these references added to your offsheet connectors. So for example, the LCD Power Enable offsheet connector goes to page 2, section B2. So if I were to go to page 2 and look around section B2, so here is A, B, so B is around here, and 2 is in this column, so I should find that somewhere in this section here, and there is my LCD Power Enable. Oh, it's actually 2B, page 1, so if I go to page 1 here, this is 2B, page 2. And I believe you can actually edit that when you do the intersheet references. There's some options on how you set that. Yeah, so it's grid and then the page. All right, so that's it for annotation. The one last thing we're going to talk about is exporting to PCB and netlisting our design. Now there's two different ways of approaching this. One is if you are planning to export your netlist into Allegro or into OrCAD X Presto, you can easily do so through the PCB option at the top here. And first thing we want to set up is the design sync setup. Because we're working in OrCAD X Capture, I highly suggest using OrCAD X Presto as the layout tool. So you can set that in the Select Layout Tool section. And what that means is when we export our netlist and select the Open Layout Tool option, it will automatically launch OrCAD X Presto instead of the Allegro tool for us. Go ahead and press OK. And then you can go into PCB, New Layout. You can choose your PCB layout folder. In this case, I recommend the default. And then name your board. Mine is going to be called howto.brd. That's just the default name. And if you have an input board from which you want to update the netlist, you can do so. But by pressing OK, you are not only netlisting the design, but also pushing the netlist into our layout tool. So we're going to press OK. It should take a second, but it'll launch OrCAD X Presto for us. And we'll be good to go. Now, if there were any errors, we would see them either here in the session log or back in OrCAD Capture in this session log as well. But here we can see that the board opened successfully and the generation of our netlist was also successful. In Presto, if you look at OrCAD X Presto tutorial series videos, you'll see how to, for example, do part placement and things like that. But we can do a quick test by going into the placement mode and, for example, choosing our U4, which is our main microprocessor, and placing it on the board. And here we can see that the footprint came through correctly, as well as some of our net names. So let's go ahead and close that for now. The other option that we have for netlisting is to simply export a netlist from our design. To do that, go into Tools and select Create Netlist. And here you'll see that there's a lot of different options for generating netlists. By default, there is a PCB Editor netlist that you can create, which is essentially the same netlist that was created in the PCB New Layout option. But in this case, it just creates the netlist file and doesn't launch the PCB tool. Maybe you want to send those netlist files to some other designer. But there's also a lot of other options, for example, for an EDIF netlist, a SPICE netlist, a Verilog netlist, VHDL. Out of the scope of this video series, but those can also all be accessed through OrCAD X Capture. Alright, so that is it. Hopefully in this short video series, you have now gained the tools you need to create your own schematic. I recommend, if you've gone through and created this schematic or a similar one, that you also watch the OrCAD X Presto layout tutorial series. It follows this schematic and does a simple layout based on these 3 pages and all of the parts that we've placed on them. But if you have created your own schematic, you can also follow along and just use the examples for the different commands to make your own layout. So again, thank you for watching. If you have any questions, comments, or even some other videos that you'd like to see, please feel free to leave any of those comments or questions below, and I will try to respond to them as soon as possible. And look forward to some other more detailed or specific videos on certain functions like the live BOM, maybe on how to design in hierarchy in OrCAD X Capture, and things like that in the future. Thanks again, and take care.